Welcome also from my side. Welcome to Vienna. It's a great pleasure for me to meet you here in person on this occasion of the European Lisp Symposium 2024. As already mentioned, my name is Markus Triska. I'm Deputy Department Head in the Department 7.5 of the Austrian Federal Chancellery. In this department, we are responsible for several important e-government services, such as the business service portal called Unternehmensserviceportal in German. This is a one-stop shop for Austrian companies where they can log in and access other e-government services via single sign-on. It also includes a content part, an access and identity management system, and so on. We're also responsible for the electronic delivery in Austria and for the implementation of the once-only principle. This means that companies and also citizens should have to provide their data only once to the administration. And the public administration should intelligently exchange the available data between different governmental units, registries, and services. We are responsible for these services, but we don't write the software. We contract this to our partners, most notably the Austrian Federal Computing Center, Bundesrechenzentrum. So we don't write the software. But we, of course, also benefit if our contractors use good technologies, most notably, of course, good programming languages. And this is why I'm here today to talk about the need for symbolic AI programming languages in the public sector. Lisp is, of course, a prime example of such a language, as already mentioned, a symbolic AI programming language designed to implement AI applications. Another well-known example of such a language is called Prolog, a logic programming language. And I think this symposium is an ideal venue, of course, to talk about this need. The European Lisp Symposium, an ideal venue. And I also think you have come to the right place, because the right place is where your great passion meets the world's deep need. Why is there this need in the public sector? Oh no, how can I can't go forward, one moment. I can't go to the next slide apparently. I simply launch this again. Let's try if I can go forward. So, why is there this need in the public sector? What is the public sector? Is this the same as a business, as a company? No, but there are obviously similarities, right? For example, both are subject to budgetary concerns, for example. Both must act according to the laws and regulations, of course. So there are similarities. There are also important differences. One very important difference is the so-called Legalitätsprinzip in German, the principle of legality. This is a constitutional principle in Austria, and it states that all acts of the public administration must be rooted in laws. Of course, not every tiny step is explicitly regulated in a law, but it must be rooted in a law. For instance, there is no law in Austria that states that a public official must hold a keynote today. But it is rooted in a law, because we are using Common Lisp in an existing e-government service in Austria, and this service benefits from the attention of experts. And the Austrian government wants to support the standardization of AI technologies, for example. This is also rooted in European regulations, for example. So it is rooted in a law. And this is why rule-based reasoning is especially important in the public sector and the public administration, because it is about laws. The executive branch, as the name already suggests, is about the execution of laws. It must apply the existing laws. It must also reason about the laws to know, for example, what is most urgent now, what must be done next. Of course, a company and a citizen is also subject to legal obligations. So it's also useful for them to know, for example, what must be done next, or this quarter, or by the end of the year, because a law prescribes it. But otherwise, a business or a citizen can do everything that's not forbidden by a law, whereas the public administration must do only what is prescribed by a law and rooted in a law. And this is why symbolic AI is especially relevant in the public sector, because it is about reasoning about laws and rules in computer science terms, maybe. It's a bit like a theorem prover also, which produces logical consequences from known axiom and by known inference rules. I know there is currently a huge hype, again, about statistical AI approaches, where we start from data, often a lot of data. And the task is to guess the laws from the data, or for example, to generate more data that's in a sense similar or analogous to the existing data. That's never the situation in the public sector. We never are in the situation that we have to guess the laws. We always know the laws. They are public information. So this is a task of symbolic reasoning, not of statistical reasoning. How do we best do this? What helps us to reason about laws, to apply laws? The laws may also change, of course. For instance, today is my first Monday in the Federal Chancellery, because last week our entire department was moved from the Ministry of Finance to the Federal Chancellery. How was this done? By changing a law. There's a law in Austria that regulates the responsibilities of the different ministries. This law was changed. As a result, our entire department and also other departments were moved. Now, such a move entails many changes: configuration changes, equipment changes, name changes. Many of these can and should, of course, be automated. How can we do this? How can we best automate these things? Which programming languages are most useful for this? One phrase I sometimes see and hear when programming languages are being discussed is that we should choose the right tool for the job. Sounds very plausible, right? It sounds plausible, but at least in my opinion, almost every word in this phrase is needlessly limiting. For instance, let's start at the right. Job. What if I don't have a job? I have a calling, or I have a hobby, or I have several jobs, several hobbies, several callings. What then? Would I not like to use a tool that's useful for many of these jobs, many of these callings? Tool. Is a programming language a tool? Yes? No? Well, it has some aspects of a tool, right? We can, for instance, apply it to solve a task, like a tool. But at least in my opinion, a programming language is different, for example, from a physical tool. Because if I introduce a programming language in an organization, then programs begin to get written in that language. So I can no longer easily replace the language, or change it, or get rid of it. That's different from a physical tool. For instance, like this watch, say, or these glasses, I can easily replace them. Not so much a programming language. Also, a tool may not be just a tool. A tool may change how I perceive the world. These glasses certainly do. The watch too. I mean, not just by its feature, but by its very existence already. It changes how I perceive the world. I may come to view the world, for example, as a resource to build more such tools. So I have a different perspective on the world just because the tool exists. Even more so a programming language. It may change, for example, my judgment about which problems I even consider solvable or worth tackling. I mean, you may not know this feeling that you are limited by a programming language. As Lisp programmers, you may not know this feeling. But talk to maybe other programming language communities, they may know this feeling that some tasks seem completely infeasible to them. So this changes my judgment. So if a language changes my judgment, it also makes it hard to even tell what is right, what is the right tool, or whether it's a right tool. And also the right tool for the job. Is there always only one right tool for the job? That seems highly implausible to me. So as I said, I at least consider almost every word in this phrase needlessly limiting. And maybe that's also not such an interesting question at all. Maybe we should not start with the question whether this is the right tool for the job, but with the question, what do we actually want to create? Which programs do we want to write? Personally, what I would like to provide is software of high quality, which brings me to the question, what is high quality software? Well, we all know examples, right? Right? Maybe not. One of my teachers said that software quality is the customer satisfaction. Sounds plausible, right? Again, yes, it sounds plausible, the customer satisfaction, but it also has a very severe drawback in my experience and my opinion. If you say that software quality is the customer satisfaction, then someone will try to measure this satisfaction. And then it becomes a quantity because you measure it. And at least in my opinion, quality and quantity are categorically distinct. I would go as far as saying that quality and quantity have a dichotomy between them. I would go as far as saying that software quality is associated with a certain disregard for numbers. Take GNU Emacs, for example. Anyone has heard of it, maybe? Okay, some of you have. It's, in my opinion, high-quality software, GNU Emacs. What do we see and what do we not see? There are no download statistics. Nobody knows how many people use it. Nobody cares which functions are most frequently executed. There is no telemetry, no spying on the user, no cost budgeting, no profits, nothing. I mean, maybe someone may know some of these numbers or partially know them, but at least as far as I'm aware, and I follow Emacs development quite closely, these numbers play no role in the development of GNU Emacs. And still, high quality software gets produced. No. In many, is there a question or some? Oh, no. Nobody changes this. No. But thank you very much. No, it's also not true. I change it. Of course, in certain situations, you do need numbers, often a lot of numbers. For instance, to run a government, you need to know many numbers. There is no doubt about it. For example, to run elections, you need to count votes. You have budget numbers. You need to know how many people you must serve, also for simple things, like today's catering, for example, which is sponsored by the Austrian government because it wants to support this event. It wants to attract experts to Vienna. Certainly, it needed to know how many people will attend. But knowing these numbers does not improve the quality of the food. No matter what you count, you won't get from quantity to quality. You may only be able to reach a certain kind of quality, maybe also in a mechanical sense, like fault tolerances of some machine maybe, but that has very limited applicability to software as far as I see. With this disregard for numbers comes what I would call masslessness. This is also something I've seen in many high-quality software products, that they are used by only a small number of people, at least in relative terms. Take GNU Emacs again. I said nobody knows how many people use it. I think what we do know that in relative terms, only a small number of people use it. Also, only a small number of programmers use it. That's something I've seen about many high-quality software products. Also, Lisp, I think, falls into this category. Only a small fraction of programmers write the code in Lisp, Prolog 2. That has certain advantages. For instance, it makes maybe organizing such a symposium easier. It may make certain discussions easier. May. It may make certain decisions easier, choosing maybe a direction of future development. It also has some drawbacks. One of the concerns, for example, when we wrote our e-government service using Common Lisp, was that there may be too few Lisp programmers who want to contribute, who want to help, and who are able to help with implementing the service and extending it. That was one of the concerns. And I think a symposium like this is also a great opportunity to show, for example, our management, that there are interested programmers, that there are people who want to work with Lisp. So mass certainly gives also a certain confidence. My recommendation is to enjoy this masslessness while it still lasts. Because once you reach a certain mass, the parasites will come. I think we know examples where there was a high-quality software product, still maybe high quality, that was used by a small number of experts. Once it reached a certain mass, the parasites came. And the temptation to sell out will become almost irresistibly. And these products, for example, then had to change their license, for example, or had to display ads or something else that reduced their quality. So enjoy it while it lasts. Taken to an extreme, and some of you may know this phrase, we arrive at the Hermit programmer. This is a phrase I once read in a discussion in Complang Lisp, in fact. I was an avid reader also of this news group, Complang Lisp, and there were always huge discussions about Lisp, yes, also about other programming languages, how good they are, and advantages and drawbacks. And I remember in one of these discussions, someone said, yeah, that's an example of the Hermit programmer working in isolation and maybe only for that single developer to write software for a single person. And as far as I remember, at least, it was not meant as a compliment. One takeaway I also got from these discussions is that I think Lisp programmers do have a lot of time for discussions, which I think is also a good sign. This may be a sign also of the power of the language, that it leaves ample time for discussions. There. In any case, I think that certainly you can achieve more as a team than as a single developer. I also think that just the fact that such a statement could legitimately be made in the course of that discussion is also a sign of the power of the language, that a single developer can achieve interesting results, implement even entire applications as a single person. Certainly, a single developer cannot, for example, implement the entirety of GNU Emacs. That's for certain. But we know from historic examples that even a single developer can achieve very usable subsets of GNU Emacs, certainly sufficient for everyday use. I think that's a great testament to the power of Lisp. And that's something I want to support and endorse, of course. That's a key attraction, to have developers that are using a language that gives them this power, that a single developer can implement, for example, an interesting e-government service. It stands to reason that a team of such developers can achieve even greater things. Sparrows on eagles is also a phrase I read in a news group, Complang APL, a programming language. This is an array-based language, and I see we have a dedicated talk about array programming later today. I very much look forward to it. And in this news group, Complang APL, Ian Clark posted an interesting article where he considered the architecture of several widely used software products, including, for example, a spreadsheet software. And the observation he made is that many of these programs are implemented like sparrows on eagles' backs, in the sense that they had a base, and then the actually used functionality implemented like an arrow on top of this eagle. And I often think about this observation, and I have since seen this architecture in many high-quality software programs, including, again, for example, in GNU Emacs, where we have a base, a Lisp interpreter, and then all of these functions, all of these packages implemented on top of this base. Lisp compilers also often have this shape. We have an engine, a Lisp engine, often maybe a subset of Lisp, and then many key features implemented in that language itself, and then libraries and packages all using that language. Prolog systems too have an engine, and then substantial portions of the system, of the compiler maybe even, written in that language itself. That's not unique to Lisp and Prolog, of course. Other programming languages also use this approach. In the context of compiler implementations, this is called bootstrapping, where you're using the language to implement already parts of that language and to extend it or to build it bottom up. That's a sensible approach, of course, because you early on get a feeling for how powerful and how enjoyable that language is to work with, and also about which features are needed. And it's an interesting design question also to consider which features must be in the engine and which must be built on top and can be built on top. So that's not unique to Lisp and Prolog. But I think that homoiconic languages like Lisp and Prolog are especially suited to implement this approach in applications, because they make it so easy to read in code, to reason about that code, to interpret the code, and also to execute it differently than, for example, the actual engine would do it. And I think that many e-government services could also benefit from this approach, that we have a base and then interesting functionality built on top of this base. And in fact, the service we implemented already, called Grants for Companies, is also an instance of this shape. the hunger for more. That's also a property I associate with high quality software, that you actually want to use it. I mean, not in the sense of an addiction that you want to scroll or swipe, but that you actually want to use the application to solve an interesting task, that you think about how you can apply it in even more situations, how you can extend the application to work in more cases. And that's something I also want to support, of course, in e-government services, that people want to use the service because it is so convenient to use, maybe so customizable, and in the future maybe also so extensible, maybe with custom code. I, for example, get this feeling again when using GNU Emacs. I know that not everybody shares this feeling for GNU Emacs in particular, but maybe you know also examples where you do get this feeling that you actually want to use the software. And I would assume that most of you get this feeling when programming in Lisp, that you want to work with the language. And that's something, of course, I want to benefit from. I want to work with programmers who want to use the language. You may have heard about the broken window metaphor, that a house or a car where a window is already broken is more likely to be broken into or to become further damaged. Because, for example, a broken window gives an indication of the social norms in that area. And that may cause people to lower their inhibitions. What I want is, of course, the opposite of this, that you think about how you can improve the software. And one thing I noticed, especially in the context of high quality software, is that once you improve one aspect of it, only then do you notice further opportunities for improvement. I think a good recent example of this is the native compilation in GNU Emacs again, implemented by Andrea, who is here. Thank you for coming, and thank you also for this feature. Thank you. That's a quantitative improvement for certain. We know that Emacs is now measurably faster, significantly faster in many cases. What I find even more interesting is the qualitative improvement, that we now can use Emacs for new kinds of applications, which previously were maybe just out of reach because Emacs was too slow. Maybe it's now fast enough for, say, an interesting computer game that was previously not possible. Now it's possible. And that in turn will make us notice even further opportunities for improvement in Emacs. Could be, for example, say, better GPU support. Or maybe a garbage collector, as mentioned, with interesting timing guarantees that are especially relevant for real-time computer games. So this improvement will make further improvements noticeable that now cannot be seen, maybe. And that's something I also noticed in the implementation of Lisp systems themselves and Prolog systems too. That once you make a simple improvement, could be a qualitative improvement like a better documentation for some functionality, could be a new kind of library, a new engine feature, or some improvement in the engine. Suddenly, it's possible to apply the system in situations that were previously out of reach or not possible. And that's something I want to benefit from too, of course, also in e-government services. That by improving certain aspects, further opportunities for improvement become possible. For instance, in the business service portal, could be maybe to make, as an example, the access and identity management system more scalable. That will enable further cooperations, for example, with new European member states, and that in turn will make us notice further opportunities for cooperation and for further improvements. One aspect I also like very much about Lisp is its timelessness. I mean that this syntax will always be here. In case of emergency, we could easily write a simple parser and even a simple evaluation engine ourselves, which would certainly suffice for a vast number of interesting e-government applications. Prolog also has this attraction. We know that this syntax will always be here. And that's, of course, an interesting attraction, especially for e-government services in the public sector. Because, for example, we have now even e-government services that were first created 30 or 40 years ago, and they are still running, and they need to be updated and adapted to the latest changes in laws and regulations. And they also need to be running far into the future. So we need technologies that we can commit to because we know that they will be available also far into the future. And Lisp, as one very established language with a long tradition, is excellently set up for this purpose. It stands to reason that it will be available also far into the future. We will always be in a situation that we will find Lisp programmers. For other programming languages, not so much. And finally, one property I personally associate with high quality software, and maybe the property that summarizes it best, is the feeling that we are in good hands. To me, GNU Emacs, again, is a prime example of this. As I already mentioned, no telemetry, no spying on the user. No distractions, no ads, no notifications. Does not require an account, for example, to even use. Does not ask me for personal data, not even for my email address. Does not force me into a subscription model. If you don't agree with a certain default setting, for example, or a certain key binding, then you can easily adjust the application. You can tailor it to suit your needs perfectly. You have the entire source code. You can study it. You can easily learn more about it. You can extend it. You can share it. You can distribute the changes. This is truly free software. And that's a feeling I want to convey too, of course, in e-government services, that people have the feeling that they are in good hands. And I get this feeling also, for example, when programming Lisp, because, for example, there is a common standard. There are ways how we can work together to ensure that the result benefits us all. And this symposium, I think, is a great opportunity for this, to meet, to discuss interesting applications of Lisp, to discuss interesting directions for future development and extensions that benefit us all. Now, here are three programming languages. I already mentioned Lisp and Prolog repeatedly. I've also included PostScript. It may not be known as an AI programming language, but it is also a symbolic language. It is also homoiconic. We can easily represent PostScript programs as a PostScript data structure, as an array of symbols, for example. It is timeless. I know that a PostScript printer, a PostScript viewer will always be present. It's fun to use. For instance, one widely used PostScript viewer is called GhostScript. And if you look at the source, then you'll see that a substantial portion of the application is itself written in PostScript. That's a sign that the language is enjoyable to use. The developers specifically chose it without any need to use it. That's a good sign. And it's also an instance of this architecture I mentioned, Sparrows on Eagles, in the sense that a substantial portion of the application is already written in that language. We see this also, for example, in Tech by Donald Knuth, where, again, the base is an interpreter for a programming language, and then substantial portions of the application already written in that language, and then all these packages, including the entire LaTeX system, also written in that language. And in fact, I've also used PostScript today because I wrote these slides in PostScript using GNU Emacs. So I've also used Lisp today, and sometimes I also use Prolog. I think there are interesting connections also between these languages. For instance, Mark, the author of Scryer Prolog, who is also here today, is working on a type checker for Shen, which uses Lisp syntax that's written in Prolog. Scryer Prolog, by the way, is also the first Prolog system which uses a very compact internal representation of strings, while Prolog programs see these strings as lists. I think that could be an interesting feature also in certain Lisp implementations. Would be an instance of this unbreaking the window I mentioned, where suddenly the language becomes much more interesting for tasks that previously nobody thought possible. I have a question about these languages. Take Lisp, for example. Suppose you knew only the language specification. Would you know from just the language specification, and maybe some sample programs even, would you know that Lisp is so nicely suited to implement a text editor? Is there any way that we can tell this? Now it's easy to tell. We all know it because we all know that GNU Emacs exists. It's easy to tell now that it's implemented. But without it, who could have guessed? And I think that may be the case for each of these languages, that there are interesting applications that will only become clear use cases for that language once the application is actually implemented. So be on the lookout for where these languages are truly useful. I think that one could run a very interesting public administration with just these three languages. Maybe not down to the bare metal at the moment. But there may come a time where we can again use these languages to the bare metal. With PostScript, for example, it's already possible. There are many printers that speak PostScript. That could make for a very interesting public administration. Now, if these languages are so great, then why are they not widely used? Why should they? One may think that once a powerful technology is discovered, or a mechanism is invented or found, then it gets immediately widely adopted. We know such examples, right? Take Git, the version control system. That's an example of high quality software that's also used by many, many people, and it spread almost overnight. Of course, it took a lot of preparatory work. It took a lot of work to get there, previous version control systems and so on. But once it became available, it was almost immediately adopted. But that's not necessarily the case. Take, for instance, the example of the chat engine. The mechanism for the chat engine was first noticed thousands of years ago in ancient Greece. We don't know how the ancient Greeks saw this mechanism. There's one source that says it's an interesting curiosity, a party trick that may remind us of something. Another source says that by studying this mechanism, we can gain insights into the laws of nature. That may also remind us of something. 500 years ago, a Spanish naval officer suggested to use this mechanism as a propulsion engine for ships. the proposal was declined. Even when airplanes were already flying, the jet engine was not yet widely used. Now it's widely used. So it may take decades, centuries, or even millennia until a powerful technology is widely used. It's not up to us to decide when this time comes. This is not up to us. But we can already today use Lisp, study interesting applications, meet at this symposium, and we can already today celebrate Lisp. No reason for applause. Because I still have one slide. I have good news. We are already using Common Lisp in an existing e-government service called Grants for Companies. We have a dedicated talk about this service later today, so let's hear more about it later. A few things I can already mention now. I led the pilot project. Philip Marek implemented it using Common Lisp in record time to show the feasibility of the approach, and my colleague Björn Lellmann is now the product owner for this service. This service is available and accessible to companies via the business service portal, and what it does is that if a company logs in and consents to the use of its data for that purpose, then the service gathers the available data from Austrian registries according to the once-only principle and uses that data to determine and display a list of grants that are suitable for that company. And it does that by reasoning about the eligibility criteria for grants. These are public information. There is a dedicated database in Austria where these criteria are stored called the transparency database. And in cooperation with the department that runs this database, we have already succeeded in formalizing more than 40 grants that are now available for symbolic reasoning. And this helps companies because it saves them time. It displays them this list of grants that are potentially suitable. And it also helps the administration because we now get an overview of the grants landscape and we can use this to, for example, detect grants that have logically identical conditions. And Lisp was very useful to implement the prototype, and we are using Lisp forms also in the productive version of the system. We have retained this syntax to remain compatible also with the prototype. We are always working on improving the service and on extending it. In the future, we will be able to automatically generate explanations for why a grant is suitable for a company or why not. To the best of my knowledge, this will be the first e-government service in Austria that can produce such explanations based on the same declarative description that's also used for the application logic. And of course, this is an example where a high quality service must also be accessible to many, many people. So masslessness certainly is not a necessary condition for high quality software. It's certainly also not a sufficient condition, just something I sometimes noticed about high quality software. Personally, when I see a situation like this, that a language attracts maybe only a small number of people, many of them experts in an area, then I also get interested in that language because I take it as a sign that the people who want to use this language do so out of genuine interest and out of some genuine power the language has, and not only because it's currently popular or because an institution has forced them to use that language. So this also attracts me to Lisp and this symposium, and that's why I'm also glad to meet you here. Let's enjoy this masslessness while it still lasts. And with this, I thank you a lot for having me here. Have a great symposium, and if you have any questions, please ask them now or in the break or anytime. Thank you. Thank you.
So, I have a question. Least space for questions. So go ahead with questions.
I don't have any questions. There's a question. Yeah, please. May I give you the microphone? I think then only people can hear it, or you have to speak into the laugh mic. Speak with love.
Okay. So Markus sent us from Canada. So question for you related to security. So in an e-government application, security must be something on top of your mind, right? So could you make some comments on that, on how Lisp helped you ensure security is all the way through in your system?
Thank you a lot. We using Lisp for this reasoning component. So our engine is not amenable to any attack from the outside, because the engine has a defined language and defined predicates that can be used to describe the preconditions or these eligibility criteria for grants. My colleague Björn Lellmann, as mentioned, is the specialist in this area and is using logical properties also, which yield a very defined language that does not allow any side effects, for example. So we have these criteria in grants for companies, and even if we were, for example, to use this domain-specific language in other applications, say, we could make easily sure that it supports only a subset of the language that is secure. And certainly Lisp makes the reasoning about such elements symbolically very easy. Prolog 2, of course. So we benefit from this symbolic amenability of the language constructs. Yeah, thank you. Good question. Thank you a lot. Another question? Yeah, please. Can I lend you the laugh mic? Thank you.
Yes, thank you for an inspiring and thought-provoking talk. There was one remark you made that interested me, and I'll paraphrase it, so excuse me if I misrepresent what you said, but I'd like to hear you expand on it a little. You made a remark that recent developments in AI often are in the area of statistical reasoning, but in the law, we use symbolic reasoning because we can be exact and we can have full knowledge. But the law must survive contact with reality. And there are uncertainties, and perhaps uncertainties even within the law. What are the limitations of symbolic reasoning in that area?
Thank you a lot. That's also an excellent question and something I want to clear also. I'm a public official working in the executive branch of the state. So I'm not part of the judicial branch, for example. I don't make judgments, I execute the law. And many things are regulated in such a way that there is no doubt about when, for example, something must happen. For example, if you don't agree with a certain decision of the public administration, then it's regulated in law unambiguously that you have, in this case, for example, 1 month to appeal the decision, to object to the decision. This is not an example where any uncertainty or probabilistic error can arise. If you, for example, then as the administration get an appeal to a decision, you can judge yes or no, is this now within the time frame where this happened or not. And this is as stated, I'm part of the executive branch, and we are focusing on those subsets where such an automatization is possible. Certainly not all instances of, not all legal problems, and there are many subtle legal problems that cannot be mechanized, that need judgment, and can and also must not be mechanized, cases where you have a right to have a human tribunal, for example. Thank you.
Small follow-up to that.
Yeah.
Even in that case, so the rule seems very strict. I suspect that in reality there are exceptions. If the person involved falls into a coma the day the decision is made, do they have exactly 1 month to apply, or their executors don't know?
Yeah.
This kind of thing.
Also a good question, and not up, certainly not up to grants for companies, for example, to decide this sample application we now implemented. One thing I also want to state here is that grants for companies is of purely informational character now. You get this list of grants. it's your decision whether you apply for a grant or not, and the decision whether you get the grant is also not part of this application. This is made by humans. You have a right that this decision is made by humans. And there are many subtle legal questions that cannot be mechanized, certainly not at the current time, and these are completely out of scope for us, but can be very interesting questions nonetheless. Thank you.
I have a question. Given that we encode this law system in some database which can be used, could such reasoning engine could be used to identify contradictions in laws so they could be fixed later on?
Yes, also a highly interesting question, and certainly one of the envisaged use cases also in this small application already is that we want to be able to detect whether these criteria are even consistent. We are currently not there, and currently is not an issue. But one advantage we have also from this formalization is that we can reason symbolically about these conditions, and certainly could apply this for this. And it's a very interesting question. And also one of the tasks I mentioned when I said rule-based reasoning, I specifically phrased it as rule-based reasoning pervades the administration. It's not only the execution, but also this reasoning to know whether this is now even consistent or whether there is a problem in the laws. Then it would, for example, also be the duty of the executive branch to point this out when it sees it is now in a situation that's impossible to recover from, for example. Thank you. Please.
I want to share an observation. When you're talking about, you introduced yourself, you are talking about different contractors that create software for the government. And I thought that it's perhaps a duty of the government to ensure the correctness and quality of the software. I mean, that the department, like your department, perhaps should be responsible for creating some framework, software framework, so to say, that will test in different ways this different software that's coming from third parties, even if they are government agencies, to ensure that they actually do what they should, right? This is a constant problem, yes, in software development, but it seems that just my observation that in e-government it's a very important part which is overlooked constantly, and maybe it's also a good venue for usage of technologies you mentioned.
Yes. Yes, absolutely. These are important points. Certainly, this is, of course, a prime duty of the contractor and also of the government to ensure that these services are implemented correctly and follow the law, especially. So also the more detailed the law is, the easier, of course, it is for the contractor. There are certain laws in Austria where they are, in fact, almost a technical specification already. We have such cases for how bills, for example, must be structured, and there's a timestamp and encryption and so on, where the law itself also includes much information that the contractor needs, and otherwise it must be specified what exactly and what are the also the service level agreements, for example, the uptime of the service and how many people it must handle are certain huge issues. Our eventual goal is certainly that these mechanisms, like also symbolic representations, can be used already at the time of the legislation. When the law is written, the eventual goal is that already when the law is written, such a symbolic representation could be included in the law. For example, to state that a grant with these criteria, which are already prescribed in this formalism using Common Lisp, for example, and that would be the grant that companies can apply for. And we can go the other way around then and generate the human readable description from this symbolic machine interpretable description. That's the eventual goal. And we will apply this in as many cases as we can. Thank you.
So you mentioned that you take care of single sign-on of only once, providing information only once, but there are other problems that citizens face when interacting with services, for example, integration. I have an example. For example, if I have to sell a car, I have to get registration data, and I have to have ownership data, and I have to collect those from different maybe authorities, and then put the listing on sale, then collect the money, and then after I get the money and do the change of ownership and so on. All these possibly need to require interacting with different services. So it's complicated for a user to do all this. And so the question is, would be a language or high-level language or an artificial intelligence system be able to assist in dealing with this integration? People have tried with software engineering technologies like web services and so on, but I don't think they have succeeded. So maybe some higher level abilities or specifications, or ability to extract specifications so that you can figure out which are the services you need to integrate and how to do that would help.
Yeah, absolutely. In fact, also to answer this specific application called Grants for Companies is an instance of a larger program we also want to put forward called Law as Code, where our goal is to represent all rules that also citizens and the company must follow, and also the government, of course, as executable or at least machine interpretable code. There are a lot, of course, of attempts to formalize such steps in databases, which I think are not expressive enough often to describe this relational reasoning that, for example, first this must happen, and then you have several possibilities maybe, and you can go to different maybe companies to do something. This could all be and should also ideally be represented in a form that it can be reasoned about mechanically. And I think Lisp forms can help a lot with this to represent flexibly conditions for when something must happen and what then should happen and which alternatives are available. Certainly in this example, and also many others, including, for example, in the medical domain, where you have certain indications for certain procedures which could and should be stored in a way that is executable and at least can be reasoned about. I think current database systems are not expressive enough for many cases, but I think that's an example where symbolic AI programming languages, notably Datalog, Prolog, also Lisp in these forms, can help to represent truly the knowledge and not just some assorted artifacts, some attributes maybe. People often speak about attributes then, but this is more than attributes. These are really relations between things that can and should happen. And for this, I think symbolic AI languages are a good representation. Thank you.
Okay,
One
I
more.
think it's done.
Yeah. Thank you.
We do have
Ja, for me, vorher langsam was rausgemacht.